Hello everyone. In this video, we're going to be talking about a financial application called amortization. And the reason why we're talking about this in chapter 3 is because amortization deals with exponential functions. It's modeled using exponential functions. So what is amortization? Amortization is the process of calculating regular payments. So if you think about an example of this, any situation where you have to make payments on a regular basis in order to pay off something. That could be a cell phone, that could be a car payment, right, or on a car loan, that could be a mortgage on a house, right, where you've taken out some sort of loan and now you have to make regular payments in order to pay off that loan. So amortization has just a nice formula that you can use for any different situation. So I want to show you that formula first, and then we're going to talk about what each piece of that formula means. So here's the amortization formula. And there's a lot going on here. Lots of different variables, a lot of calculations going on. So let's break up each piece. And I want to start with this left side. This left side, you might recognize. This is the compound interest formula. Now, there's a reason why we're learning this after 3.5, because if I consider t as my independent variable, then this counts as an exponential function because your variable is in the exponent. But I don't have base e. Instead, I have this whole expression as my base. Now, this might look familiar. We've seen something similar to this. We've seen something like this, pe to the rt. And if you remember, this represents my formula for interest that's compounded continuously, right? We use base e if we ever have continuous exponential growth, meaning it's not just growing at specific times, it's growing continuously. But this compound interest formula doesn't work that way. Instead, it works where the interest is only growing a certain number of times each year, a finite number of times each year. And that's actually what the n represents. N equals the number of times the interest is compounded in a year. So, for example, the simplest example of this, if you're only earning interest one time of year, then n would equal 1. If your loan waits until the end of the year before you earn interest on it, your n would equal 1. But another common example of this is monthly compounding. If you think about situations where you have monthly payments, that means your interest is being compounded monthly. So n equals 12 represents monthly compounding. And we're going to use that for our monthly payments. I think all the problems on your homework deal with monthly payments. So n equals 12 is really what we're going to be using for all the homework problems. But there's still lots more variables to talk about. So what is P? If this is my compound interest formula, then P is going to represent the initial loan amount. That's initially what I borrow, and then I'm earning interest on that loan. What is R? R, of course, is just the interest rate. T, of course, is time, but in this situation, what commonly happens with loans is you take out a loan for a specific amount of time. So even though we recognize t as our variable, in most of these cases, t is going to be given to you. So that takes care of the left side of the equation. And really what that left side is measuring or is tracking is how big is your loan getting as time goes on. So the left side is calculating the size of your loan. The right side, on the other hand, is calculating something called annuity, which represents how much you're paying or how much is getting paid off. So that's what the annuity measures. And you'll notice it uses a lot of the same variables that we used earlier, right? R represents the interest rate, N represents the number of times it's being compounded, so it's going to be 12 for monthly payments. T represents the length of the loan, but there's one more variable here that we need to talk about, and that's this lowercase p. I tried to make that obvious that it's the lowercase p. That lowercase p is your monthly payment. Actually, I shouldn't say monthly because monthly would only be if n is equal to 12. So this just represents my regular payment. How much am I paying on a regular basis? If n is equal to 1, then it's an annual payment. If n is equal to it's 365, then it's a daily payment. But remember, on the homework, you'll be talking about monthly payments, so n will equal 12, and that's what P will represent as your monthly payment. But that's our formula. And so let me rewrite it again so it's a lot clearer, and we can get away from all the notation that I made, and we can go through this once again. P, capital P, is your initial loan amount. And this right side of the equation tracks how big the loan is getting. R is your interest rate, N is the number of times it's being compounded, probably 12 because it's a monthly amount, and T is the length of your loan. And we're going to set that equal to how fast you actually pay off the loan, with lowercase p representing how much you're paying on a regular basis. So there's your formula, and that's what you're going to be using on all of the homework problems for 3.6. So go ahead and get started on the homework, try out a few problems, see how you do, and if you get stuck, go watch my examples video. In my examples video, I go through an example where they actually have a down payment. And so if you're curious about how that affects things, go watch my examples video because I'll talk about how a down payment plays into this whole thing. Okay, good luck, guys, and I'll see you in the next video.